big open contact style relay up here. This is actually an automotive type of relay stuck under here. Yeah, there's a computer grade filter cap here, kind of hanging in the breeze. Got a lot of cables running around. Here's another wee-way. Hey, welcome D-Lab everybody. This is part 2 of the Ranger that has the strange humming caused by a push-to-talk circuit that is running at 120 volts AC. I contacted the owner. I explained the issue to him and said the best way to remedy this is to remove the AC from the push-to-talk circuit and get it to a low-level DC so that hum is not induced into the microphone. So what we've agreed to do is install the D-Lab K2 board. The current relay, it's right here in my hand, it's a 4-pole relay and the coil is 120 volts. So as to not interrupt the other modifications that this Ranger has, the K2 also has 4 poles of switching. So I'm simply going to install this and move the wiring around to accommodate the new module, and we'll test it at that point. I don't want to get in here and just start gutting everything and cause more problems. We're going to take this one step at a time. First step, put in a safe push-to-talk system. So here we go. So if you recall from my initial video, we had this crazy wire harness that came out of the back of the Ranger on these pigtails, and they were using this for manual activation of the transmitter plus the spotting function. Okay. Also, the rear jack has been replaced with a Drake style TRS jack, and this red wire, which is the push to talk line, goes to this relay. Then we got this other cable here which switches 120 volts, and that is what was pulling in the current push-to-talk relay. So I traced the 120, goes on this wire harness, swoops up here, goes right by the audio input tube for your microphone. So that is more than likely where the AC is inducing into the preamp section. Then that goes up, of course, feeds push-to-talk relay. So this is really the issue, but the best way to eliminate that is to remove it because it shouldn't be there in the first place. So what I'm going to do is remove this relay. We're going to get all this additional wiring out of here, hook up the D-Lab push-to-talk system, retest, and see if the hum is gone. So what's the best way to start the reversal process? Start cutting. Okay, a lot of this is not very well documented, if at all. Okay, but since I'm simply going to install the new push-to-talk system, I really don't care about this stuff anymore. Okay, because I've committed myself now, guys, cutting everything out, right? So now it's on me. I really don't understand what all this was about, but we're going to get it nice and neat and functional again with the new push-to-talk system. Well guys, I'm in pretty deep now. We got all 3 of the relays hanging in the breeze. This was the 120 volt feed that went up through the audio section. Lots of relays. Okay, so these are out. Now this one here looks as though they wired it into the VFO spot switch. Remember I told you that externally the crazy wire harness had a MOX and spot function, so I believe that's what this was for. This guy is a 12 volt DC relay. This one is also a 12 volt type that you'd have like in your car. This one is an open frame Potter and Brumfield, and it's a 6-volt relay. So I'm trying to figure out where he got a hold of all these voltages, because there's no power supply in here, right? So that's a mystery, but it's not one that I'm going to solve, because that's going away. So pretty much at this point, I'm going to change the rear mic jack. We're going to put in a 4-pin style. That's what the owner requested. We'll rewire the 6AX4 socket for the push-to-talk module. These wires here had been disconnected and went through the crazy system, but these will be joined back together, and then I'll just have to detangle the mess on the VFO spot switch. At that point, I think we can try the push-to-talk system. Progress report time. I've got the new 4-pin mic jack installed. Luckily that hole hadn't been opened, so she dropped right in. This blue wire is the new push-to-talk line, which goes over here down to the base of the 6AX4 pin 4. These wires used to go to the VFO spot switch, so I still need to get that reconnected. Then we'll move topside and wire in the new push-to-talk module. Alright, it's time for the critical portion of this task. I've got everything underneath wrapped up. Everything looks good. I don't think there's going to be any issues under there since all those relays are gone. So now I need to change out the main push-to-talk relay, which is a 120 volt coil. And what we're going to do is put in the D-Lab K2 push-to-talk relay system. So that means these diodes here for the 6AX5, that base is coming out. Mine goes here. I have to remove this socket. But first, before I do that, I need to map out where all these wires are going. Remember, there's other modifications to this radio, okay? There's switching bias and some other craziness. I need all that to stay as it was until I install my module and see what else has issues, okay? I need this guy to operate like it did with this 120 volt relay, but instead we're only going to have 12 volt DC in the microphone. Alright, quick update. I have the K2 module installed. I am now transferring the wires from the old socket onto the new module. One thing I wanted to point out, you see that hole right down there? That was one of the mounts for the old relay socket. They used a sheet metal screw. It happened to go through and went right into the back of a terminal board, and it was probably within 20-30 thousandths of shorting out 2 terminals. A successful installation of the D-Lab K2 push-to-talk module into the old 6AX5 rectifier tube socket, switching 12 volts DC to the microphone jack rather than the AC that was present before, causing hum. I also wanted to replace this 5R4 diode system with the original tube because I'm kind of concerned about the increase in high voltage. But when I plugged in the tube, it didn't light up. I thought, oh boy. Took a look underneath. Somebody has removed the filament wires. I don't know where they're at. I'm not going to tear the whole thing apart to find that out, because at this point I need to test the Ranger. At this point I'm just going to test the Ranger into the dummy load, make sure metering on the Ranger looks correct, make sure I have power, and of course modulation without hum. I've got the D104 hooked up to the new 4-pin mic jack behind the radio. I'm going to move the camera over in this direction so you can see the operation, but I'm absolutely sure the Ranger's audio problem is solved. After I verify this on the bench, then I'll take it into the radio room and we'll actually listen to the audio on my National 300 receiver. Here's some information that I failed to cover during the repair of the Ranger. This is the updated schematic from the person that did the modifications. If you take a look at the microphone input jack, you'll see the switching went to a 6-volt AC relay coil. That was the open frame relay that I showed in the transmitter that the push-to-talk line was going to. So if you follow this little diagram, you'll see that you had 6-volt AC going right into the microphone. And here was his wiring. Tip was push-to-talk, ring was the mic, and of course ground. So that was the source of the stray AC that was ripping up the audio, and that now is gone. I'm going to tune the Ranger on the 40 meter band. Let's go to phone, check our grid, it is present. Go to plate, we're still in phone. And there is my plate, and she's dipping. Modulation now. This is where we had issues that you didn't actually see, but as soon as I keyed it, the meter would deflect and there was hum on the signal. So there is my static modulator current. Hello. And you can see on the meter here, the watt meter, idling around 40 watts. I got all kinds of forward modulation. I can actually hear the audio coming out of the modulator tubes. That's a good sign. Alright, so now I'm going to take the Ranger into the ham shack and we will monitor the audio on my National 300. So now we're going to test the Ranger monitoring the audio on my National 300 receiver. The 300 receiver at this point does not have an antenna connected. I've got the coax over here hanging in the breeze. We're still into the dummy load, so I'm going to have to control my audio level on the 300 so that we don't get any feedback. But what we're looking for is to see how pure that audio is. I also put the Ranger back in its cabinet for this test. In the past, I find that if you check a transmitter out of its cabinet, you'll get increased buzz and all kinds of strange RF activity going on that will make you believe there's a problem with the transmitter. So it's always a good idea just to slide him in his cabinet before you test the audio. So here we go. We're on 40 meters still.
Hello, 1 2. Hello, 1 2 3 4. And there she is, guys. A little feedback there, but as you can hear, nice, clean, powerful audio. I think we're in good shape.
So we're going to do another test with a little more RF gain. I'll back down on the audio gain to control feedback.
Hello, 1 2 3 4. 4 3 2 1. So there she is, guys. Crystal clear.
I believe we've solved the issues with the Ranger. So D-Lab is going to take a mission accomplished on the unmodding of this little Johnson Ranger. See, I told you guys I was up for the challenge. Although it's not my favorite thing to do, it was necessary or this beautiful Ranger would be unusable. Okay? It actually turned out to be a little bit easier than what I thought because I removed more things than I put in. So what's the takeaway from this video? If your Ranger's working and it sounds good on the air, don't modify it. And if you do modify it, take that thing to the grave with you. Because if you send it down the road, the next guy gets a hold of it and there's problems and it does not match the documentation. Okay? Johnson engineers knew what they were doing, and if they had any problems, they would go out and do revisions to that circuit. All my Johnson transmitters that I run are pretty much stock. The only thing that I have modified is the push-to-talk system, and that's just because I didn't want hazardous voltages in my microphone. Other than that, I leave them the way they were designed. It's easier for me to work on, and it's easier for you to work on if you get a hold of it later on, right? So guys, that's the best thing I can recommend. Enjoy the hobby, but don't get in there and modify things because you may be causing more trouble than what it's worth.